Hey, what's going on guys? In this video we are going to see how to find the operating mode of a BJT. There are two methods we can use. The first method is we assume this BJT is in active mode. In order to be active mode, VC has to be greater than VB. So we are going to solve this circuit and see whether we get VC greater than VB. If it's true, then it's active mode. If it's not satisfied, then it's in saturation. This is the first method. The second method is we assume this is in saturation mode. In order to be in saturation mode, beta has to be greater than beta minimum, or we can say beta first. We say beta first because we forcefully assume this is in saturation. Now beta first can be calculated using IC saturation over IB saturation, and from that we see that whether if this satisfies this condition, it's in saturation. If it's not, it's inactive. Now we are going to use the first method. We assume this is in active mode. If we assume this is in active mode, this is the main thing we have to notice. VBE has to be 0.7. That's the first thing. Now based on that, we are going to solve this one. Like we apply KVL and find the currents, and after we find the currents, everything is going to be easy. Okay. Now this is IB current going through this one. Okay, let's apply KVL here. If you apply KVL at this, since this is going from negative to positive, this negative 5 voltage, and here we have 100K times IB plus 100K times IB, and then here we have 0.7 plus 0.7, and then like this is VBE. Okay, VBE has to be 0.7 in order to be in active mode. So 0.7, and after that we have IE 1K plus IE times 1K, and that's it. That should be equal to 0. This is a KVL around here. Now IE, this is like whenever you have arrow like this, it means these two currents are entering and this is exiting. So you can say this is collector. Like you know that this arrow means this is emitter part, emitter base collector. So this current is IC current. Okay, so we know that IE has to be addition of these two because these two are entering and this IE is exiting. So IE has to be equal to IC plus IB. Now if I want to write this one, let's see. And also we know that IC can be written as beta times IB. Okay, so instead of IC, if I replace this one with beta times IB, we can say beta plus 1 times IB is equal to IC. Okay, I just took IB common because beta times IB is equal to IC. So and we have IB. If I take IB common, this is going to be beta plus 1 times IB. And if I replace this one here, it's going to make this one easy because if you replace, that's going to make this one just one unknown variable, IB only. So let's go ahead and write this one again. This is going to be minus 5V plus 100K IB plus 0.7. Instead of IE, I plug this one. Beta plus 1 times IB times 1K, that's equal to 0. Now here we have, okay, let's go ahead and remove everything else other than IB. Here we have minus 5, here we have plus 0.7. If we add them, that's going to be 4.3. okay, and also okay, let's add this this one. Beta is what? Beta is given 100. So 100 plus 1 times 1K, that's 101K IB. And here we have 100K IB. And I'm moving the others to the other side. So minus, this is 0.7 voltage. Minus 5 plus 0.7, that's 4.3. If I move to the other side, that's going to be positive 4.3. And if you add these two together, this is going to be 201K IB is equal to 4.3. Therefore, IB is equal to 4.3 divided by 201K and that's going to give us 0.021 milliampere, or you can say 21 microampere. Okay, this is the IB value. Now we have the IB value. The next thing is we can find out, since we have IB, we know that beta times IB is equal to IC. So IC is equal to beta is 100 times IB is what? 0.021 milliampere, and if you multiply, this is gonna become 2.1 milliampere. IC is 2.1 milliampere. Okay, we have IC, we have IB. The next thing is we know that IE is equal to IC plus IB. IB is 0.021, and then IC is 2.1, so this is going to be 2.102. IE is going to be equal to IC is what? 2.1 plus 0.021, so this is going to be 2.102. Now this is our IE value, milliampere. Okay, now we have IC. Our main thing is to find out VC is greater than VB. If we find this one out, and if it satisfies this one, this is an active mode. If it's not satisfied, it's in saturation mode. Okay, now let's see that. Now in order to find VC, we have to know VCC, that is this one, minus IC times RC. Let's calculate. We have 10 voltage minus IC, we calculated that one to be 2.1 milli times RC is 1K. So milli K cancels each other. 10 minus 2.1, that's going to give us 7.9. Okay, so this is 7.9. Now let's go ahead and calculate what is VB is. We have IB, we calculated that one here, 0.021 milliampere. Okay, we have IB times this one is going to IB. Okay, first we have to calculate VE, then we have to move to calculate VB, because we know that the voltage has to be, VB has to be 0.7. So if we calculate VE, that's going to give us, like, we can find VB from that. Now VE is what? IE times 1K. IE, we calculated that one to be 2.102 milliampere. So 2.102 times 1K, that's going to give us VE. So VE is going to be 2.102 voltage. Approximately we can say 2.1 voltage. So if it's 2.1 voltage, then we know that VBE has to be 0.7. VB is nothing but VB minus VE. Now VE is 2.1. If I subtract from that value, that's going to give us 2.7. So from that one, we know that VB has to be 2.8. In that way, if we subtract VE from that, that's going to give us 0.7, right? So VB is 2.8. So now we know that VB is 2.8 voltage and VC is 7.9 voltage. And in order to be in active mode, VC has to be greater than VB. Here you can see VC is greater than VB. So this is satisfying this condition. Therefore, this is in active mode. And that's how we figure out whether a BJT is in active mode or in saturation mode. I hope this helps. Thanks for watching.